we're going to use L'Hopital's rule to evaluate the limit as x approaches minus 2 of 3x cubed plus 16x squared plus 28x plus 16 divided by x to the fifth plus 4x to the fourth plus 4x cubed plus 3x squared plus 12x plus 12. So first thing we're going to do when we attempt to evaluate this limit is see if this function is continuous at x equals minus 2, in which case the value of the function and the limit are one and the same. So if we plug in minus 2 for x, we end up with 0 in the numerator, and you should check this for yourself, and 0 in the denominator, which says that this function has an indeterminate form of 0 over 0 at x equals minus 2. That means we can apply L'Hopital's rule, and L'Hopital's rule says the following. We can spell L'Hopital's rule this way or also like this. But we'll abbreviate it by L apostrophe H. Now, L'Hopital's rule says the following. If limit as x approaches a of f of x over g of x yields indeterminate form 0 over 0. Now, there are other indeterminate forms that can occur, but since in this problem we have an indeterminate form of 0 over 0, we'll frame L'Hopital's rule using this indeterminate form. So if this limit gives us indeterminate form 0 over 0, then we can compute the limit as x approaches a of the derivative of the numerator f prime of x over the derivative of the denominator g prime of x. This is not quotient rule of differentiation, just derivative of the numerator over the derivative of the denominator, and this limit is equal to L. That means that the original limit, that is limit as x approaches a of f of x divided by g of x, also is going to be L. And the L could be a finite number or infinity or minus infinity. So let's go to our problem again. We'll return to the limit we're trying to evaluate. Limit as x approaches negative 2 of 3x cubed plus 16x squared plus 28x plus 16 divided by x to the fifth plus 4x to the fourth plus 4x to the third plus 3x squared plus 12x plus 12. As we just saw, this gives us indeterminate form 0 over 0, which means we can apply the L'Hopital's rule and evaluate the limit of the ratio of the derivatives. So this is the same as limit x approaches minus 2. Derivative of the numerator will be 9x squared plus 32x plus 28. Derivative of the denominator is 5x to the fourth plus 16x to the third plus 12x squared plus 6x plus 12. Now, evaluating this limit, once again, we want to see if this function is continuous at x equals minus 2, in which case the limit and the value of the function are the same. But again, if we plug in minus 2 for x, we come back and get indeterminate form 0 over 0. So it seems like L'Hopital's rule has failed, but if we think about it, we can now apply L'Hopital's rule to this quotient and look at the limit of the derivatives of the numerator over the denominator. So this is now, by the second application of L'Hopital's rule, equivalent to the limit as x approaches minus 2 of the derivative of the numerator 18x plus 32 and the derivative of the denominator 20x cubed plus 48x squared plus 24x plus 6. So now let's go ahead and plug in minus 2 for x. In the numerator we have minus 36 plus 32, which is minus 4. And in the denominator, plugging in minus 2, we get minus 8 times 20, which is minus 160. And then 48 times 4, which is 192, plus 24 times minus 2, which is minus 48, and then plus 6. So this is equal to, in the denominator, minus 208 plus 198, which is negative 10. So we end up with minus 4 divided by minus 10, which is simplified to 2 over 5. So let's summarize what we just did. We applied L'Hopital's rule twice, and we can, if we ended up after the second application with 0 over 0, we would apply it for the third time as many times as necessary until we end up with something else other than 0 over 0. So the summary is the limit as x approaches negative 2 of 3x cubed plus 16x squared plus 28x plus 16 divided by x to the 5th plus 4x to the 4th plus 4x cubed plus 3x squared plus 12x plus 12. This limit after two applications of L'Hopital's rule is equal to 2 over 5. Now, before we end this problem, let's go back to the method we used in Calculus 1 whenever we had a limit of a rational function that gave us indeterminate form of 0 over 0. We would factor each polynomial, and that can occur here. So using that method, the numerator factors, again, you should try to check this, into x plus 2 squared times 3x plus 4, and the denominator factors into x plus 2 squared times x cubed plus 3. Now you can see the reason we had 0 over 0 is because of x plus 2 over x plus 2, and because of the square in the numerator and denominator, you can now see why L'Hopital's rule had to be applied twice. It had to be applied each time to eliminate the power of x plus 2. We can now cancel x plus 2 over x plus 2. Plug in minus 2 into the numerator. We get minus 6 plus 4, which is negative 2, divided by, in the denominator, minus 8 plus 3, which is negative 5. And of course, we get the same answer of 2/5. For more videos, visit www.mathprepvideos.com.